Today we're going to talk about writing equations using parent functions and transformations from graphs. Some of the general equations that we have already looked at are listed on the screen. As you can tell, they all have an a, h, and a k value in common. From our discoveries, we know that the h and k values tell us our locator point, or how the function has been translated horizontally and vertically. And our a value tells us how the graph has been vertically stretched or compressed. Now let's take a look at an example of how to write one of these equations. So here's this graph. The first thing that we want to do is determine which family function this belongs to. Based on this shape, we can tell that it belongs to the cubic family of functions. Now we want to determine where the locator point exists so we can find our hk values. This locator point is going to be at the coordinate point -2, 1. This tells us that our hk value is going to be -2, 1. We're going to take the general form of the cubic equation, which is y equals a times the quantity x minus h cubed plus k, and we are going to substitute in -2 and 1 for the respective h and k values. So we will now have y equals a times the quantity x minus a -2 cubed plus 1. We can simplify this x minus a -2 to an x plus 2. So we have y equals a times the quantity x plus 2 cubed plus 1. We now need to solve for the a value. In order to do this, we need to locate another coordinate point on our graph that is not the locator point. So we have this point up here, 1, 10. This represents an x, y coordinate point, which we can use to plug 1 and 10 into the x and y variables in our equation. So we have 10 equals a times the quantity 1 plus 2 cubed plus 1. We want to start simplifying this before we solve for the a value. So we have 10 equals a times 3 cubed plus 1. 3 cubed is going to give us 27. So we have 10 equals a times 27 plus 1. And now we want to get a all by itself. So we are going to subtract 1 from both sides. So we have 9 equals a times 27. And then finally we're going to divide both sides by 27. So 9 divided by 27 is going to reduce to 1/3, giving us our a value. Now that we have the a value, the h value, and k value, we can write our entire equation. So for this function, we have y equals 1/3 times the quantity x plus 2 cubed plus 1.